You hear about artificial intelligence all the time, right? But how does a machine actually learn anything? Well, today we're going to pull back the curtain and demystify that exact process, step by step. And really, it all comes down to a pretty simple question. How does a machine look at a bunch of random pixels and somehow confidently say, yep, that's a cat? It sounds like magic, but it's not. It's actually a surprisingly logical process of trial and error, kind of like how a student crams for a big test. So, here it is. This is the roadmap for how it all works. Just think of an AI as a student. First, it looks at the study material. Then, it makes a guess on a practice test. It gets a score back, figures out what it got wrong, adjusts its way of thinking, and then it does it all over again, and again, and again, and again. We're going to walk through this exact loop right now. Okay, so first things first. Just like any student, an AI can't just learn in a vacuum. It needs stuff to learn from. It needs data. This is its version of textbooks, lecture notes, and practice exams. Now, this study material can be, well, pretty much anything. It could be something simple like a spreadsheet with columns for age and income. Or it could be the raw pixel data from millions of photos or huge libraries of text. Or even the super complex waveforms of audio files. The AI's job is to dig through all of this and start finding the hidden patterns. All right, so our AI has its study material. Now it's time to take the test for the very first time. In the world of AI, we call this the forward pass. It's basically the process of information flowing forward through the AI's brain to produce that initial guess. See, the network is built from millions of these things, artificial neurons. And you can just think of each one as a tiny little calculator. It takes in a bunch of information, multiplies each piece by a weight to decide how important it is, adds it all up, and then makes a really important decision. Is this signal strong enough to pass on to the next neuron in the chain? And that decision, that fire or don't fire signal, that's called activation. And honestly, this is the whole ballgame. Without it, an AI, no matter how big and complicated, could only learn super simple straight-line patterns. But with activation, it can start to understand the messy, complex, and curvy relationships that actually define the real world. This is what gives AI its power. So after all that data flows through layers and layers of these neurons, each one weighing info and deciding whether to fire, what pops out at the very end? A prediction, the AI's first best guess. And let's be real, it's almost definitely completely wrong. Okay, and this is where the magic really happens. It's one thing to know you got an answer wrong. It's another thing entirely to understand why you got it wrong. And this whole process of learning from mistakes, that's called backpropagation. You know, before you can fix a mistake, you have to know just how bad it was, right? That's the job of the loss function. You can think of it like the teacher's red pen. It compares the AI's guess to the actual right answer and spits out a single score. This isn't an A or a B, it's just a number that tells you exactly how far off the AI was. High number? Bad. Low number? Good. And yeah, that first time through, the loss score is going to be ridiculously high. The whole goal is to crush this number down to get it as close to 0 as we can. So, that's the big question, isn't it? The AI has this terrible score. It knows it failed. How does it actually get smarter for the next try? Well, the answer is a process called backpropagation. And this, my friends, is the absolute secret sauce of modern AI. The system literally works backward from that big error score, flowing in reverse through the network. It's like an investigation, asking every single connection, hey, how much did you contribute to this mess? So this process basically acts like a detective. It takes the report from backpropagation and figures out which connections, which of those little weights screwed up the most. And then it just nudges them. A tiny, tiny adjustment in the right direction to be a little less wrong next time. That small correction is the act of learning. So, great. The AI has seen the data, made a guess, got graded, and adjusted its thinking. Is it smart now? No. Not even a little bit. One tiny adjustment isn't going to cut it. To really learn, the AI has to do this over and over and over again, and that is the training loop. We call one full pass through all the data an epoch, and you can just think of that as one big study session. An AI doesn't train for just one epoch. It might train for hundreds or even thousands of them. And with every single epoch, all those little nudges add up, and that big, scary loss score gets lower and lower. The AI is actually getting smarter. And just like a smart student, AIs have a few tricks up their sleeve to learn better. They study in small, manageable chunks called mini batches. They use a cool technique called dropout, where they randomly ignore some of their own neurons. This forces them to learn the real concepts instead of just memorizing the answers. They even create new study examples for themselves, like flipping or rotating an image, just to get a deeper understanding. Okay, so let's bring this all down to earth. Because this loop we've been talking about, guess, check, adjust, repeat, this is the engine that powers pretty much all the AI you interact with every single day. Just look at how this plays out in the real world. For a retail company, the study material might be your age and income, and the test is predicting if you'll buy something. For image recognition, the study material is pixels, and the test is telling a cat from a dog. For a business, it's spending history, and the test is predicting if a customer is going to leave. The details change, but the learning loop, it's always the same. But I gotta clear something up. You always hear about deep learning, right? Which just means a network with a ton of layers. But is deeper always better? The answer is nope, not at all. For clean, structured data, like a spreadsheet, older, simpler models are often way better. Deep learning really starts to shine when you have massive, messy, unstructured data, like millions of images or all the text on the internet. So there you have it. That's the secret. A simple cycle of guessing, measuring how wrong you are, and making tiny corrections, but repeated millions and millions of times. That is how a machine learns to see a cat. This simple loop is the engine of our entire AI revolution, which leaves us with one heck of a question to chew on. What happens when machines use this very process to discover a fundamentally better way to learn all by themselves?